All right, let's break down a fantastic question from the June 2022 GCSE Physics paper. It's a classic problem, and it's all about a toy airplane, a spring, and the, honestly, beautiful physics of energy transfer. So here's how we're going to tackle this. We're going to split it into three simple parts. First, we'll get into the big calculation, finding the plane's speed. Then, we'll quickly nail down the exact name for the energy involved. And finally, we'll think about how we could make this little plane fly even higher. Ready? Okay, let's get into the main event. This is a multi-step calculation, and it might look a little intimidating at first, but trust me, it follows a really clear, logical path. We're going to go from the energy stored in the spring all the way to the speed of the plane. So here's the setup. We've got this little toy plane, right? And it's ready to fly. Our job is to figure out its maximum possible speed the very instant it's launched. And the best part is, the question gives us every single clue we need to solve it. It's all right here. And these are our key numbers, our raw ingredients. We've got the spring constant, K. That's just a measure of how stiff the spring is. We've got the extension, E. That's how far we've pulled it back. And of course, the mass of the plane itself, M. Now let's see how these all fit together. So, the very first thing we have to work out is how much energy we've stored in that stretched spring. It's called elastic potential energy, and we find it using this awesome little formula. Half times the spring constant times the extension squared. And now, we just plug in the numbers we were given. So we take 0.5, we multiply it by our spring constant, which is 50, and then by our extension of 0.12 squared. That gives us 0.5 times 50 times 0.0144, which works out to our total stored energy. And there it is. Our stretched spring is holding exactly 0.36 joules of energy. That number is absolutely crucial. That's our starting point, all that energy just coiled up and waiting to be released. And this brings us to one of the most fundamental, most important rules in all of physics, the conservation of energy. It's a big deal. It means that the 0.36 joules of energy we just calculated, it has to go somewhere. It can't just disappear. So where does it go? Well, for a question like this, we assume it's a perfect system. And that means every single bit of that elastic potential energy from the spring gets transferred directly into the plane's energy of motion. Now, this is where it gets really clever. The energy of motion is called kinetic energy. And its formula is half times mass times velocity squared. And would you look at that? There's the V for velocity, or speed. That's the thing we're trying to find. Because energy is conserved, we can just set the two types of energy equal to each other. The elastic potential energy we started with must equal the kinetic energy the plane gets. So our 0.36 joules equals the kinetic energy formula. From there, it's just a bit of algebra. We simplify, rearrange things to get V squared all by itself, which gives us 36, and then we just find the square root. And just like that, boom, we have our final answer. The plane launches at a maximum speed of 6.0 meters per second. How cool is that? First part of the question, done. Okay, we've done the heavy lifting with the math. Let's move on to the next part, which is really just a quick knowledge check based on what we've already figured out. So the exam paper asks for the specific name, the scientific term for the energy stored that's all about the plane's motion as it zips away. And the answer, straight from the official mark scheme, is just one word, kinetic. It's the kinetic energy store. That's it. A nice, simple point after all that calculation. All right, on to our final section. Now that we really understand how this whole system works, we're asked to think like an engineer for a moment. How could we improve this launch? Now, the question uses proper physics language here, gain more gravitational potential energy. But let's be real, what it's really asking is much simpler. How do you make the plane fly higher? So the official mark scheme gives us a couple of great options. The big one, the main physics answer, is to increase the extension of the spring. If you pull it back further, you store more energy to begin with. Remember that formula? The extension is squared, so a tiny bit more stretch gives you way more power. Of course, you could also just aim higher, increase the launch angle. That works too. See, it all comes back to that one core idea of energy transfer. The more energy you can cram into that spring at the very beginning, the more kinetic energy the plane has when it's released. And the more kinetic energy it has, the higher it can climb. It's a perfect chain reaction. So, what's the big takeaway here? Well, this whole principle of converting stored or potential energy into motion or kinetic energy, it isn't just for exams. It's literally everywhere. You see it when you stretch a rubber band, when an archer draws a bow. You even see it on a massive scale with water held behind a dam. So, the question I want to leave you with is, where else do you see it? Thanks for joining me.